Hey guys, it's Mr. Davis. In this video, we're going to talk about Pythagorean triples, and I got two big hints for you. Big hint number one, you're going to want to make sure that you draw the triangle. And big hint number two, write down your work. If you can draw that triangle and write down your work, you'll find that these problems are super duper easy. So let's go through one of these problems. Which group of numbers form a right triangle? Do you see that there's three numbers in each of these groups? The word triple means three. So a Pythagorean triple is three normal looking numbers, three pretty numbers, three rational numbers that all form a right triangle. So we're going to see which group of these works, and only one of them does. So let's start with here on the left. Let's start by drawing my right triangle. An absolutely gorgeous right triangle. And let's plug in the numbers here. I know that my smallest two numbers are always the legs. The legs of my triangle are always the smallest numbers, and the biggest number is going to be my hypotenuse. So we're going to check to see if this works. Does 4 as a square plus 5 as a square equal 6 as a square? See, 4 to the power of 2 plus 5 to the power of 2. And my question is, does that equal 6 to the power of 2? Let's see, 4 times 4 is 16. 5 times 5 is 25. Does that equal 6 times 6? 16 plus 25 is, let's see, 41. And so does 41, equal 6 times 6. And you already can see 6 times 6 is 36. And is 36 the same as 41? No. That is not going to be a right triangle. It is still a triangle, but it's definitely not a right triangle. Now, because I was wondering if this is true, instead of putting equal signs, we're going to put an equal sign with a question mark. That's the math way of writing, are those the same? So, did they work? No. Let's try this one over here. 6, 8, and 10. I start by drawing my right triangle. And let's see, my smallest two numbers, 6 and 8, are going to be the legs. And my largest number, 10, is my proposed hypotenuse. So my question here is 6 as a square plus 8 as a square going to be equal to 10 as a square? Did you notice that I put that question mark over the equal sign? That's how I'm asking, are these the same? And now let's see. 6 times 6 is 36. 8 times 8 is 64. So is 36 plus 64 going to be the same as 10 to the power of 2? 36 times 64, 36 plus 64 is 100. So is 100 the same as 10 to the power of 2? Well, what is 10 to the power of 2? 10 to the power of 2 is 100. And is 100 the same as 100? Yes. So, which group of numbers form a right triangle? And the answer would be 6, 8, and 10. Your turn. Why don't you see which one of these two groups form a right triangle? When you're done, hit play to check your answer. All right, let's do it. Here on the right, or excuse me, on the left, I'm going to make a right triangle. My smallest two numbers, 7 and 24, are the legs. My biggest number, 25, is the hypotenuse. The Pythagorean theorem says I take the legs as squares, and they should equal my hypotenuse as a square. And let's see, what is 7 times 7? It's 49. Ooh, I need a calculator. 24 times 24 is 576. So my question is, does 49 plus 576 equal 25 to the power of 2? 49 plus 576 is 625. And does that equal 25 to the power of 2? Well, let's see, what's 25 times 25? 625. So is 625 going to be equal to 625? Well, of course it is. So yes, this group makes a right triangle. Well, how about this one over here? We might as well check it to make sure that I didn't make any mistakes. Here we go. There's the right triangle. My smallest two numbers are my legs. My largest number is the hypotenuse. And going through, I see does 5 as a square plus 10 as a square, is that going to be equal to 15 as a square? And now let's see, 5 times 5 is 25. 10 times 10 is 100. So, is that the same as 15 to the power of 2? Well, what is 25 plus 100? That's 125. So, is 125 the same as 15 to the power of 2? Oops, I did that in the wrong color. Is it the same as 15 to the power of 2? Well, let's see. What is 15 times 15? That's 225. And so the obvious question here is 125 the same as 225? No. No, it is not. No. So, which one of these groups forms a right triangle? Right there. All right, why don't you try this problem? Make sure you draw your triangles. And when you're ready to check your answer, hit play. Here we go. Let's form the right triangle on the left. The smallest two numbers are my legs. So that's the 3 and the 8. The biggest number is my hypotenuse. Did I trick you? I tried. And so here we go. 3 as a square plus 8 as a square. And that's going to equal 12 as a square. 3 to the power of 2 is 9. Plus 8 to the power of 2 is 64. And my question is that going to be the same as 12 to the power of 2? Let's see, 9 plus 64 is 73. And is that going to be the same as 12 to the power of 2? Let's find out. 12 to the power of 2 is 144. And is 144 the same as 73? Nope. So those do not form a right triangle. Let's try here on the left, 13, 5, and 12. So here's my right triangle. My question is, does 5 and 12, if those were the legs of a right triangle, would I get 13 as its matching number? And so let's find out. 5 as a square plus 12 as a square, does that equal 13 as a square? Let's see, 5 times 5 is 25. 12 to the power of 2 is 144. Does that equal 13 to the power of 2? 25 plus 144 is 169. And does that equal 13 to the power of 2? 13 to the power of 2 is 169. So is 169 the same as 169? The answer is, of course, yes. Since those are the same, this group of numbers forms a right triangle. Go ahead and try this problem, and then hit play when you're ready to check your answer. All right, so right triangle, the smallest two numbers are my legs, so 18 and 30. My question is, can the hypotenuse be 32? Well, let's see. 18 as a square plus 30 as a square, does that equal 32 as a square? 18 to the power of 2 is 324. 30 to the power of 2 is 900. And is that the same as 32 to the power of 2? Well, 324 plus 900 is 1,224. And is that the same as 32 to the power of 2? Let's find out. What is 32 to the power of 2? 32 to the power of 2 is only 1024. Is 1024 the same as 1224? Nope. So that is not a right triangle. Let's try over here on the left. Let's not just assume it's correct. Let's check it. Let's make our right triangle. Our smallest two numbers are my legs, 33, 44, and my biggest number is the hypotenuse, 55. The Pythagorean theorem says that the area of the two small squares adds up to the area of the big square. So does 33 as a square plus 44 as a square equal 55 as a square? 33 as a square is 1089 plus 44 as a square, which is 1936. My question is, does that equal 55 as a square? Let's find out. 1089 plus 1936 is 3025. And is that the same as 55 to the power of 2? Well, let's find out. 55 to the power of 2 is 3025. And is 3025 the same as 3025? Well, of course it is. So yes, this group forms a right triangle. That forms a right triangle. Two more. Try this one. Which one of these forms a right triangle? When you're done, hit play to check your answer. All right, starting here on the left, I form my right triangle. My smallest two numbers are the legs. My biggest number is the hypotenuse. And so 9 as a square plus 40 as a square, is that going to be equal to 41 as a square? And let's see, 9 times 9 is 81. 40 to the power of 2 is 1,600. And is that the same as 41 to the power of 2? 81 plus 1,600 is 1,681. And is that the same as 41 to the power of 2? 41 to the power of 2, I can type in my calculator, and I get 1,681. And is 1,681 the same as 1,681? Well, yeah, of course it is. Yes. Beautiful. That's a terribly looking yes. Let me fix that. Make it prettier. There we go. Yes. So I know that this group works. We might as well check the other group while I'm here. And so let's take a look. I form my right triangle. And let's see, my smallest two sides are my legs, 10 and 25. My biggest side is the hypotenuse. The Pythagorean theorem says that the area of the squares formed from the small sides should equal the area of the square formed from the large side. So does 10 as a square plus 25 as a square equal 31 as a square? 10 to the power of 2 is 100, plus 25 to the power of 2, which is 625. And is that going to be the same as 31 to the power of 2? 100 plus 625 is 725. And is 725 the same as 31 to the power of 2? And let's see here, 31 to the power of 2 is 961. So does 961 have the same worth or value as 725? Of course not. No. So those groups do not form a right triangle. Last one before I show you a little trick. So go ahead and see which one of these groups of numbers forms a right triangle. Which one is a Pythagorean triple? All right, let's check it. I'm going to form a right triangle. The smallest two numbers are my legs. The biggest number is my hypotenuse. If these numbers are a Pythagorean triple, then 18 as a square plus 20 as a square should have the same value as 27 as a square. And let's see, 18 to the power of 2 is 324. 20 to the power of 2 is 400. And my question is, does that have the same value as 27 to the value of 2? 324 plus 400 is 724. Does that have the same value as 27 to the power of 2? Well, let's find out. 27 to the power of 2 is 729. And is that the same as 724? No, it's close, but for this to be a Pythagorean triple, those would have to be exactly the same. So that is not a Pythagorean triple. How about this group? 14, 28, and 50. Well, let's find out. I'm going to make a right triangle here. My smallest two are my legs. My largest one is my hypotenuse. And so leg as a square plus leg as a square should equal the hypotenuse as a square if it's a right triangle. Does 14 to the power of 2 plus 28 to the power of 2 equal 50 to the power of 2? 14 to the power of 2 is 196, plus, let's see, 28 to the power of 2 is 784. My question is, does that equal 50 to the power of 2? Let's see, 196 plus 784 is 980. And is 980 going to be the same as 50 to the power of 2? Well, what is 50 to the power of 2? 50 to the power of 2 is 2,500. Is 980 the same as 2,500? No. No, it's not. Oh my goodness. Which group forms a right triangle? Neither. We always go through and double check our answers by checking each problem. We don't want to just assume that the right answer is on there, because sometimes it won't be. Now, these things that I've been checking are called Pythagorean triples. So here I've got a Google page, and we are going to pull up Pythagorean triple. Let's Google that together. Pythagorean triple, Triple. Now you can see that there's a whole list, Pythagorean triples list. These are numbers that always form a pretty right triangle. And I want to show you something really cool here. I have actually been using these numbers on purpose in class, and I don't do that forever. But these numbers are the most common ones, especially these first ones that you see here. 3, 4, 5. Oh, let's not do it that way. Let's highlight it. 3, 4, 5, 5, 12, 13, 8, 5, 17, 7, 4, 25. I just showed you guys right here. I did a 9, 4, 40 on this example. All of those are our Pythagorean triples. But any combination of numbers that has that same idea will be a Pythagorean triple. So let's take 3, 4, 5, and let's times all of those numbers by 2. So if I took 3, 4, 5, and I multiplied them each by 2, let's make it a little two-way table here, I would get, let's see, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. And guess what? That's a Pythagorean triple. What if I times it all by 3? Well, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. That's also a Pythagorean triple. In fact, if I were to times it all by 11, 3 times 11 is 33, 4 times 11 is 44, 5 times 11 is 55. That was one of the problems I gave you. If you go through and you memorize a few of these Pythagorean triples, especially these early ones right here that I've highlighted, you will see where Mr. Davis and all your other math teachers get the math questions that they come up with. We are using that idea. It's very common. When you're looking for 3 rational numbers that all form a right triangle, they're either going to be on our Pythagorean triple list, or they're going to be one of our Pythagorean triples that we've multiplied to. Anyway, good job, guys. This was fun, and we will see you next time. Bye.